All right, so today we're going to be talking about the subset subproblem. The subset subproblem is a mathematical question which involves a target number and a set of numbers that could potentially add up to become that number. And the question is, of that set, which numbers can actually add up to become that number? Generally, this cannot be solved with logical programming and requires something like a genetic algorithm in order to actually figure it out. In order to understand the genetic algorithm, there's a couple concepts to understand, and I'm going to try and cover those quickly. So the first concept to understand is population. A population is a collection of potential solutions to the given problem, and each solution is represented by a chromosome. In this code, a chromosome is defined by a Boolean array, which represents whether a number is included in the subset or not. The second concept to understand is selection. Selection is the process of actually choosing chromosomes from the current population to be parents that produce offspring. The next concept to understand is crossover. Crossover is the process of combining two parent chromosomes to produce one or more offspring. This actually mimics the process of biology. This crossover method takes two parent chromosomes and produces two offspring, and uses a random crossover point and swaps the genes that point between two parents to produce the offspring. The next concept to understand is mutation. Mutation introduces small random changes into the offspring, and this is essential for maintaining genetic diversity in the population and helps to avoid premature convergence to a suboptimal solution. This mutation method iterates over each gene of the chromosome with a small probability of flipping its value. And the final concept to understand is actually fitness. Fitness is a measure of how good a solution is concerning the problem. The fitness of a chromosome is calculated by measuring how close the sum of the selected numbers are to the target number. And that's the main points. I'm going to run the program. And I actually came up with a GUI for this program just so that it's a little easier to use. And so for our set, I'm going to choose a total of 8 elements. And I'm going to, let's see, so we're just going to come up with some random numbers like 3, 6, 10, 12, 15. I'm going to put a 1 in here, maybe even a 2, and we're going to put in a 20. And then we're going to come up with the target sum. I'm just going to choose 37, and we're going to run the program. And it looks like this one actually hit on the first generation. Seems to be pretty good. This time it took 2 generations. The first generation, you can see it hit 38, and then the second generation was 37. And so I ran again, and it looks like it actually was unable to solve it this time. So it took 100 generations, which is the max amount of generations that I set for this. Generally, if I were to maybe set this higher, it could maybe even hit that 37 number. But this time it didn't, and this time it did it on the first time. Some challenges that were involved in producing this. Really, the main challenge was just wrapping my head around the genetic algorithm itself and the different parts that it took to understand it, and then translating that into code. And then the GUI took a bit of time, but that was more for fun. So thank you very much.